In this module, we describe the principal dimensions and turning radius of the Boeing 767-300. The wheelbase is 74 feet 8 inches or 22.76 meters. The nose gear is located aft of the flight deck. Keep this in mind for taxi turns. The span of the horizontal stabilizer is 61 feet 1 inch or 18.62 meters. The distance from the ground to the top of the vertical stabilizer is 52 feet or 15.85 meters. The distance between the main gear struts is 30 feet 6 inches or 9.30 meters.
Here we show the wingspan of the Boeing 767-300 freighter with and without winglets. On this frame, we show the turning radius for a non-winglet equipped Boeing 767-300. On this frame, we show the turning radius for a winglet equipped Boeing 767-300. This frame shows the flight deck layout of the Boeing 767. Provisions are available for up to 6 people in the flight deck. This allows for a crew staffing of 2, 3, or 4, and the loadmaster as applicable.
You should know that especially for Cat 2 and Cat 3 approaches, when visibility of the runway and runway environment are critical, an improperly adjusted seat can reduce your visibility by hundreds of feet. Therefore, follow the steps on this frame to learn how to properly adjust your seat to obtain the optimum eye reference position. The flight deck is equipped with 6 windows as shown here. Some windows are electrically heated for anti-ice and anti-fog. The left and right side windows, L2 and R2, can be opened from inside the flight deck. Window R2 can be opened from outside the flight deck.
This panel contains most of the controls and indicators of the various aircraft systems. You will notice that this panel is subdivided into 5 longitudinal rows of systems, control panels with their switches, indicators, and indicator lights. You may notice that very few gauges are located on this panel. For example, the aircraft has no voltage and frequency displays for the electrical system. Advanced automation has removed the requirements for certain displays and gauges. In addition, displays for APU operation and hydraulic pressure are displayed in a digital format on the ICAS display located on the center instrument panel. The forward instrument panel is divided into a left, center, and right panel. The left and right forward panels contain the primary flight and navigation displays.
The captain's instrument panel also holds the standby flight instruments and the standby engine indicator. The first officer's instrument panel holds the brake, accumulator pressure indicator.
The engine indicating and crew alerting system screens are located in the middle of the forward instrument panel. The 2 ICAS CRT screens display the engine instruments, messages of the crew alerting system, and system status messages. As you can imagine, the ICAS system is a focal point for operation of the aircraft. Flight crews must be able to interpret and use the checklist to respond to ICAS messages. We will provide a training module for the ICAS system. The center part of the glare shield is made up of the Mode Control Panel, or MCP, that contains the controls for the Autopilot Flight Director system. Immediately to the left and right of the MCP are the 2 VOR DME control panels. These panels can be used to manually tune VOR frequencies, although normally the VOR panels automatically tune as directed by the FMS to receive radio inputs for position determination. The master caution and warning lights are located outboard of each VOR panel. These lights illuminate for certain caution and warnings, which are also displayed on ICAS and/or discrete lights. The forward electronic control panel is located immediately in front of the center forward instrument panel and contains the controls for the two ICAS computers and the two ICAS CRT screens. This forward panel also holds the two control display units, or CDUs, that are used to interface with the flight management computers, or FMCs. The controls for the secondary flight controls and the major engine controls are located on the control stand. The aft electronic control panel contains the VHF radios, audio control panels, fire control panel, and various other system controls and indicators. The accessory panel is located on the right side wall behind the first officer's seat. It contains switches used primarily by maintenance to test and extract digital information from the ICAS computers. The accessory panel also contains the oxygen mask for the second observer and a bookcase. Due to the unique control switches in the cockpit, the next few frames will provide guidance to the purpose and operation of these switches. Instead of old-style toggle switches, the 757-767 system panels incorporate an extensive use of push-button switches. Two types of push-button switches are used: alternate action and momentary action. On some switches, part of the switch may contain an indicator light that illuminates when a system fault has occurred, or the light may simply indicate the system status. Let's look at each switch type in more detail. Alternate action switches assume different positions when pushed to on and when pushed to off. With the switch in the on position, when pushed again to off, the switch protrudes from the panel. These switches are typically used to select a valve to open, switch on, or valve to close, switch off. Another example of an alternate action switch is an engine pneumatic bleed valve switch. Notice that when in the on position, the switch is flush with the panel, an illuminated flow bar is displayed, and the off light remains illuminated until the valve actually opens, with the engine pneumatic pressure opening the valve. Other system alternate action switches have an on designation superimposed on the flow bar associated with the on position. Examples of these kind of switches are the fuel pump switches. Finally, other alternate action switches simply indicate on and are not equipped with the shutter and flow bar. An example of that type of switch is an anti-collision light switch. The lower part of the switch contains a line signifying that there is no label for that part of the switch. This type of switch is spring-loaded to the extended position. When pushed to the on or off position, this switch returns to the extended position. An example of a momentary action switch is the external power switch. We'll explain. The external power switch is currently shown in the off position. The available light merely indicates that the external power of the correct voltage and frequency is connected to the airplane, but not currently in use. Now, when this switch is pushed into the panel to on, the on light in the switch illuminates, but the switch returns to the extended position. Therefore, with this type of switch, you cannot determine the on-off status by observation of the switch position, but rather by the lamp indications on the switch itself. Another example of this type of switch is the pack reset switch. There are only a few of these types of switches. They are generally used to activate-deactivate systems or to reset system operation. 3 incandescent dome lights, 2 forward above the captain's and the first officer's seats, and 1 aft light behind the captain's seat, provide cockpit general area lighting. Integral instrument lights, panel faceplate lights and floodlights provide panel illumination. Semi-portable utility lights and chart and map lights provide miscellaneous lights for pilot individual use. The controls for these lights for the 757 and 767 aircraft are located on the overhead panel and on the end panels of the glare shield. The cockpit dome lights are variable intensity lights, but go to full brightness when the light override switch is pushed to on. If normal dome light electrical power, ground service bus is lost, the battery bus automatically powers the forward lights at a fixed intensity. If normal electrical power is lost, many lights are automatically switched to the standby AC bus. These lights are the standby magnetic compass light and floodlights for the forward panels. In addition, the integral lights for essential instruments on the left forward, center forward, and the overhead switch panel are also switched to the standby AC bus. The rotary dim bright switch allows the dimming of all indicator lights on all the panels. However, the standby power off light on the overhead electrical panel cannot be dimmed. An indicator light auto bright system provides 2 levels of illumination for all indicator lights. The system automatically overrides the dim selection of the indicator light selector and switches the indicator lights to full bright for the following conditions: loss of equipment cooling airflow, an example, left recirculation fan not operating, or equipment cooling system supply fan failure. Cockpit ambient light level increases to the preset crossover light level as detected by the auto bright system sensor located on the instrument panel. The flight deck dome light, interior and exterior lights, and forward entry door 1 left lights are powered by the emergency lighting system to provide illumination for evacuation of the flight deck. The emergency lights are powered by a battery pack and are maintained by the aircraft's electrical power when the emergency light switch is selected to off or armed positions and the aircraft's electrical system is powered. The lights can be turned on manually or automatically if aircraft electrical power is lost or turned off. With the switch in the armed position, all emergency exit lights illuminate if normal electrical power fails or is turned off. The switch on position activates the lights without any electrical power loss, but turns on the emergency lights on armed light. A corresponding ICAS advisory message of emergency lights is generated as well. Selecting the switch to off prevents emergency lights operation. Again, the unarmed light illuminates. A number of different light systems make up the exterior lights. Included are landing, taxi, runway turnoff, position, anti-collision, strobe, and wing illumination lights. The controls are located on the overhead switch panel. You can turn the lights on and off by use of this free play panel. The wing landing light intensity is at maximum only when the landing gear lever is in the down position. The nose gear landing lights and the taxi lights work only when the nose gear is down and locked. This module describes the operation of the Boeing 767 cabin doors and emergency exits. All cargo entry doors operate the same. They're manually operated and can be opened from inside or outside of the airplane. The cargo entry doors are plug type and during opening will first move inward and then upward into the ceiling. The doors are counterbalanced, so less effort is necessary than you would expect for operation. The ICAS advisory message, left forward entry door displays, and the entry door's light on the overhead panel illuminates when the left forward entry door is not closed, latched, and locked. On this frame, you can click the left forward entry door to simulate opening and closing of this door. Observe the ICAS advisory message, left forward entry door, and the illumination of the entry door's light on the overhead panel. A single converted freighter entry door is located at the left forward side of the aircraft. The door is equipped with a viewing window, recessed door assist handles, and a door control and mode selector panel. When opened, the door first moves inboard, then upward into the ceiling. The door is counterbalanced for ease of operation and is held open by a latch in the upper part of the door frame. To close the door, raise it up and push the up latch release button, then lower the door about 2 inches. Release the button and continue to lower the door. We now show the door controls and will demonstrate the operation of normal door opening from the inside. Here you can see that the door is armed for emergency operation, so we must disarm it before opening, or the slide will automatically deploy and inflate. You can determine a door is armed by observing the yellow armed indicators, the position of the slide arming lever, and the displayed emergency-only armed indicator. The converted cargo freighter door is not equipped with a slide raft. An escape rope, installed over the center portion of the upper door frame, provides a means of egress from the main deck cargo area. The escape rope is used in the same way as the flight deck window emergency egress system. The passenger entry doors can also be opened from the outside, whether the emergency mode is armed or not armed, because the door is automatically disarmed when the exterior handle is used.
Pushing the exterior control handle in will disarm the door, then pulling the handle out unlocks and unseats the door. From this point, you can lift the door upward until it is held up by the door open latch.
Main cargo compartment access is through a main cargo door located on the left side of the aircraft, forward of the wing. The door is controlled electrically and is powered by the ground handling bus. The main deck cargo door opens outward and is hinged at the top and latches and locks on the bottom and sides by mid-span latches. Cargo loading lights are installed and operated by a switch on the main cargo door control panel.
Operation of the main deck cargo door is accomplished on the main deck cargo control panel. To open the door, pull and hold the lock-unlock switch to the unlock position until the arm and door not latched lights illuminate. When both lights illuminate, release the switch. Then pull and hold the open-close switch in the open position until the door fully open light illuminates. To close the door, pull and hold the open-close switch in the closed position until the door fully open, door not closed, and door not latched lights extinguish. Release the switch.
There are 3 lower cargo doors, one forward, one aft, and one bulk. The forward and aft cargo doors are located on the right side of the aircraft, while the bulk cargo door is located on the left side of the aircraft. The forward and aft cargo doors are operated electrically and open upward and outward. These doors may be operated manually as well. The bulk cargo door is an inward opening door and can only be operated manually.